Today we are going to start with a new topic, that is law of conservation of momentum. Law of conservation of momentum. Law of conservation of momentum. First of all, what does this mean? Before starting this particular topic of conservation of momentum, I will give you example. Suppose there are two brothers in a house. Okay, there are two brothers in a house. This is the complete house. Okay, this is the house. You can call it as a system. You can call it what? As a system. There are two brothers. In the complete house, let the total amount be 100. Both of them have the total amount, how much? Rupees 100. Suppose Mr. A has 40 rupees and Mr. B has 60 rupees. Yes or no? Inside the system, how much rupees is there? 100 rupees. One of them have 40 and another person B has how much money? 60. In this case, what is going to happen? Suppose after some time they both had a fight. They both had a fight. Very tremendous fight. Jabardast fight. Okay? They both collided. And Mr. A was a little powerful as compared to Mr. B. He took 30 rupees from Mr. B. Okay? Now, this person A will have how much money? 70 rupees. And the person B will have how much rupees? 30 rupees. Now also the total amount of money is how much? 100. During from here to here, the money has neither been spent and neither money has came into the house. In both the cases, this is what? Conservation of money. Before the fight and after fight, the total amount remains same. Now this I am going to apply in law of conservation of momentum. Let's see. But in this case, suppose there are two bodies. Suppose there are two bodies. Body A and body B. Body A and body B. Its mass is MA. Its mass is MB. Okay? Both of them makes a system. Both of them together makes a system. This is a complete system. Okay? Suppose body A is moving with velocity UA and body B is moving with velocity UV. Body A is moving with velocity UA and body B is moving with velocity UV. Let UA is greater than UV. The velocity of A is greater than velocity of B. What is going to happen in this case? After some time, after traveling, after some time, what is going to happen? A is going to strike ball B. So, at certain instant, A and B collides with each other. In that case, ladai was there? Yes. Now, in this case, both are, what is happening? Colliding. This is A, this is B. At the time of collision, A is applying the force on B, and at the same time B is applying the force on A according to Newton's third law. As you know that forces always occurs in pairs. So A will apply the force on B and B will apply the reaction force on A. Okay. After the collision, the ball A and ball B will start moving with VA. Okay. Body A will start with moving with VA and body B will start moving with velocity VB. Yes or no? Yes. Okay. Now just see the heading. Law of conservation of momentum. Law of conservation. Conservation means? Conserve. Conserve means it's not wasted out. It is not decreasing. Okay. In last case, what? The money was being conserved before the collision and after the collision. In that case, in this case also, before the collision, the momentum of the system is you are going to calculate, and after the collision, you are going to calculate the momentum. In both the sum will become what? Same. Equal, same. So let's start. Initial momentum of system. Initial momentum of system is equals to Pi. Pi is equals to P initial of A plus P initial of B. Yes or no? P initial of A plus P initial of B. P initial of A. What is the mass of A? Ma. What is the velocity of A? Ua. So you can write P initial of A is Ma Ua. Yes or no? Ma Ua plus momentum of B is how much? Mb Ub. Yes or no? This is the P initial momentum of the system. Okay. After collision, initial momentum of the system before collision. You can write like this. Before collision. Now, let it be final momentum of system after collision. Yes or no? Final momentum after collision. What is going to happen after collision? This body A is moving with velocity Va. This body B is moving with velocity Vb. The momentum of A will be MAVA. Momentum of B will be MBVB. Yes or no? The system has P final. P final is equals to P final of A plus P final of B. That is equals to MA VA plus MB VB. Yes or no? It is P final. Now, what we are going to do here, let this equation as equation number 1 and this equation as equation number required to prove according to this one required to prove. What is that? P initial is equals to P final. If this both will be equal, then law of conservation of momentum is valid. Okay. Now let's see. In law of conservation of momentum, we are going to use both the laws, Newton's second law as well as Newton's third law. So what is going to happen? Let's see. At the time of collision, let's see. Ball A is applying force on ball B. So this is the direction of force on B due to A. Force on B due to A. And this is the force on A due to B. Yes or no? Both will be in opposite direction. Force on B due to A and force on B A due to B. At the time of collision, according to Newton's third law, force on B due to A is equals to minus of force on A due to B. Force on B due to A is equals to minus of force on A due to B. In this case, what is going to happen? Force on B due to A is equals to minus of force on A due to B. Now, this one is taking place due to Newton's third law. And you have studied in Newton's second law, force is what? Rate of change of momentum. So this force is applied on which body? This force is applied on body B. This force is applied on body B. And this force is applied on body A. So the force applied on body B will change the momentum of body B. And force applied on A will change the momentum of body A. So let's see. change in momentum of body B according to Newton's second law. According to Newton's second law, according to Newton's second law, delta P, change in momentum of B upon delta T, is equals to minus of delta of A, momentum of A upon delta T, where delta T is time of collision, time duration of collision. Yes or no? Time duration of collision. So, as you can see, on both the sides, on the numerator there is delta T and delta T. Till as A will apply the force on B, for the same time B will apply the force on A. So in both the cases delta T in both the cases are same. Delta T in both the cases are same. Just cut it down. Just yes or no? So from here we are getting delta PB is equals to minus of delta PA. Delta PB means change in momentum of B. What is the change in momentum of B, beta? Initial momentum is MB into UB and final momentum is MB into VB. So change is how much? Final minus initial. That is can be given by MB VB minus MB UB. Yes or no? Any problem here? Just put the negative sign. Change in momentum of A, MA VA minus MA UA. Yes or no? MA UA. In this case, MB VB minus MB UB minus of MA VA minus MA UA. Just open the brackets. Let's see. MB VB minus MB UB is equals to, just open the bracket, this minus will go inside the bracket, it will become this minus and this minus will become plus. MA VA minus MA UA minus MA VA. When this minus sign will go inside, MA VA will become negative and MA UA will become positive. So just interchange the negative terms from left to right and right to left. Take MBUB in that side, take MAUA this side. MBVB plus MAVA, but this negative will become positive. MAVA is equals to, this is MAUA plus MBUB. Now you can see what is the first equation. MAUA plus MBUB. MAUA plus MBUB is what? P initial. Yes or no? MAVA plus MBVB is what? P final. So P final is equals to P initial. This tells you what? Law of conservation of momentum. P final is equals to P initial. This is the complete law of conservation of momentum for class 9. Okay.